Hello students, today's unit is states of matter. When I'm telling you that today we will be talking about states of matter, I think the reaction is very obvious. Ma'am, we know all these things. What new you are telling to us? Solid, liquid, gas, these are the three states. Yeah, agree. You are correct. But, oh ma'am, again but. Yes, my dear children, being a science student, these are very important terms for you people. But why, how? You should be very, very curious about the things happening in your surrounding. Only then you can enjoy the beauty of science. How beautiful is science? No? So for this, be very, very familiar with all these terminologies. Yes, you people know about these three states of matter, but today we will be talking about in much detail because you have only studied the bulk properties of different physical states. What do I mean by bulk properties? Like if I talk about boiling point. Boiling point. We know about this very well, but the liquid starts boiling when its pressure becomes equal to atmospheric pressure. This is the simple definition of boiling point. But an individual molecule of liquid does not boil. In bulk, boils. Similarly, you all know water has wetting property. But an individual molecule of water do not wet. So, this was about bulk properties which you have already covered. And on changing the states of matter, when we change the physical state, their properties entirely changes. But this does not affect the chemical properties. But one more important parameter is this, that although the chemical properties remain same by changing physical state, but rate of reaction changes. Very important point. Note down that by changing physical state, chemical properties remains unaffected, but rate of chemical reaction, it changes even to large extent. That's why it's very, very important for us to know the different laws which decides the characteristics of a particular physical state. So, before talking about those laws, we should know why under similar external conditions, one substance is existing in solid state, other in liquid, other in gaseous state, like at room temperature. H2O is liquid. It is liquid. Then oxygen, it's a gas. Why it is so? When all other external conditions are same, then why the physical states are different? The two main parameters which are responsible for the state of a matter are, the first one is intermolecular forces. Second one is thermal energy. We will be talking about these parameters in detail also. The balance of these two factors decides the state of a particular substance. Got it? The state depends on what? The two basic parameters are, one is intermolecular forces and the second parameter is thermal energy. Balance of these two parameters decides the state of substance. Now first we talk about intermolecular forces. What do we mean by intermolecular forces? The attractive and repulsive interactions. Force of attraction and repulsion among the particles of matter is termed as intermolecular forces. Next definition we will be discussing about van der Waals forces. A new term for you, no? Intermolecular forces you have already studied in 10th standard, but you haven't talked about van der Waals forces. This name is given on the basis of discoverer to honor the discoverer J. van der Waals. That's why these forces are termed as van der Waals forces. Now, what do we mean by this term? The attractive interactions, not repulsive. Only the force of attraction between the particles of matter are termed as van der Waals forces. Means the attractive interactions are given a terminology of van der Waals forces. How many types of van der Waals forces are there? Type of van der Waals force depends on the type of matter. What kind of substance is given to us? Now, what do we mean by kind of substance? Kind of substance, in bonding unit we discussed there are two types of bondings, ionic bond and then covalent bond. And in covalent further two types of molecules are there. One is polar and the second is non-polar. So on the basis of these kind of nature, chemical nature, we have different types of van der Waals forces. Let us begin with first category, where both the molecules are polar molecules. Because the force can take place between two polar, between two non-polar, between one polar and one non-polar, between ion and a polar molecule, ion and a non-polar molecule. In this way, total 5 types of forces are there. So, let us begin with the first type, that is when both the molecules are polar in nature. So, the name of this force is dipole force. First type of van der Waals force. Dipole force means both the molecules are polar in nature. Both molecules are polar. Children, can you help me? What do we mean by polar molecules? Now, please don't disappoint me, because in a previous unit we talked about polar molecules in detail. Yes, you people are telling me correctly. Polar means where electronegativity difference was present between two atoms. Such as, for example, yes, what can I take? Good, I can take HCl. This is first HCl molecule. In neighborhood, we will be having another HCl molecule. So as we know, chlorine is more electronegative than hydrogen. So this shared pair of electron remains attracted towards chlorine. Due to this attraction of shared electron pair towards chlorine, chlorine becomes slightly negative, hydrogen becomes slightly positive. Now here van der Waals force comes in picture. Negative pole of chlorine and positive pole of hydrogen, they experience a weak force of attraction. It's very weak, not strong. Don't get confused. Why weak? Because partial charges are there. These are not full charges. As partial charges are there, so of course weak force of attraction is present. And this weak force of attraction between these two opposite poles is termed as dipole force. So understood the meaning of dipole force? It takes place among two polar molecules and the causes force of attraction between two opposite poles, and a very weak force because Slight charges are there, not full charges. So any polar molecule you can take. But again, be very, very conscious when you are deciding this. It's not every polar molecule, although I'm saying every polar molecule, but still you need to be careful, such as here I'm again confusing you, yes or no? But I will clear your confusion very soon. Suppose I give you H2O. Is it a polar molecule or not? Of course, it's a polar molecule. But can I say here type of force is dipole-dipole? No. Because here hydrogen is coming with oxygen. And whenever hydrogen comes with oxygen, nitrogen and fluorine, which force is there? H bond. Clear enough? This is hydrogen. Stronger as compared to dipole-dipole. Why stronger? Because this is more electronegative. This force is taking place between the molecules where electronegativity is very high. So, be very careful whenever you are deciding about dipole-dipole force. Wherever hydrogen comes with what? Nitrogen, oxygen and fluorine. In that category, the type of force is hydrogen. Remember? Good. Now, talking about another case where one molecule is polar and the second one is non-polar. In that case, what kind of force is present? Name of that force is dipole, induced dipole. Dipole, induced dipole. Dipole means one molecule is polar and the second one is non-polar. Now, how force of attraction takes place among these two. And what do we mean by induced dipole? Meaning of dipole, you all know so well. Such as HCl, we discussed, it's a polar molecule. But when it comes in contact with a non-polar, any example you can take hydrogen, chlorine, nitrogen, oxygen or any organic molecule like methane, carbon tetrachloride, any example, so many are there. Suppose we are having HCl molecule, example of polar, and H2 molecule, example of non-polar. In HCl, the shared electron pair remain attracted towards chlorine, giving chlorine slight negative charge, hydrogen slight positive charge. But in H2, symmetrical distribution of this electron cloud, so no apparent charges are there. But here what happens? Suppose you are sitting with your friend is interested in self-studies, but you want to go for outing. You are insisting your friend also that please let us go for outing. यार कुछ फर्क नहीं पड़ता, थोड़ी देर में वापस आ जाएंगे. But that person is resisting. No, I have to complete this thing. This is my target for today. But still you are keep on pushing. No, please let us go with me. I can't go alone. I need your company. Slowly what happens? उसको भी आप बिगाड़ लोगे और ले जाओगे अपने साथ. This is happens here, that this increased electron density on chlorine starts repelling the symmetrically distributed electron cloud of hydrogen molecule. Because we know similar charges, they repel each other. So this increased electron density here will start pushing the electron cloud of hydrogen molecule, which was although symmetrically distributed, but still due to this impact, it will start pushing it, and it will push this electron cloud in right direction towards that side. Means it will induce polarity in this non-polar molecule. This is the meaning of induction. Means influencing anything without touching. That is induction. So, it will induce polarity in this non-polar molecule. Now, due to this shifting of electron cloud towards right side, again here delta positive, here delta negative charges appear. Although the strength of these charges even weaker than these charges, because this is not real polarity, this is induced polarity. Got it? Now, of course, whether it is induced or real, polarity is there. And when polarity is there, these opposite poles, they will attract each other. So now this weak force of attraction, this is termed as dipole, induced dipole force. Understood, my dear children? What do we mean by dipole? Induced. And the third type of force is instantaneous dipole. Instantaneous dipole, induced dipole. This force is also termed as dispersion force, or London force, to honor the scientist who discovered this force. Now, what kind of molecules or atoms are present in this category? Instantaneous dipole, induced dipole means both are non-polar. No polarity is there. Both are known. Any examples? So many examples we talked in previous force: hydrogen, nitrogen, oxygen, chlorine, and so on. How force of attraction takes place between these two molecules. Although they are non-polar. But if you remember, every covalent bond has certain ionic characteristics. This was given by Fazan's rule. Remember this concept that every covalent bond has certain amount of ionic characteristics. Now, how these characteristics comes when already both the molecules are non-polar? Symmetrically distributed electron cloud is there. Like if this is a case of H2 molecule, this is hydrogen molecule, all electrons are symmetrically distributed. Same electron, this is electron cloud. You know? What does we represent? This is electron, symmetrically distributed electron cloud all around. We say electron cloud, orbital concept is there, given by Schrodinger wave equation. That's why we talk about electron cloud. You can imagine this with suppose you have a ball filled with pebbles. So, and you are rotating this ball. So, along the ball, pebbles are also rotating. Of course, they are symmetrically distributed. But at any instant of time, suppose you tilt a ball to little bit, all those pebbles, they go towards one side. Same happens here also. Then, in case of H2, we know electrons, they are not stationary particles. They are continuously moving around nucleus, as well as they are spinning on their own axis. All these things we have already studied. No confusion about these things, I think so. Right now? So, when electron clouds, they are rotating around nucleus, during that, might be at a particular instant of time that electron cloud shifted towards a particular direction. At that particular moment, dipole is introduced. That's why we call this dipole as instantaneous dipole or even momentary dipole, we may call that. Because at a particular time moment, that dipole is appeared. So, we can represent that momentary dipole in this way, like this. When electron cloud is shifted towards a particular dipole. This was the first situation. This is the second. Symmetrical electron cloud. Symmetrical distributed electron cloud. Same here. But this becomes now instantaneous dipole or momentary dipole. instantaneous dipole. And when this instantaneous dipole comes into picture, this end becomes delta positive, this becomes delta negative. And now the picture is clear to you. What happens when here dipole appears? It will repel its electron cloud, push towards right side, means this symmetry gets disturbed. It will induce polarity in the neighboring molecule. So here polarity is induced by this first one. So this is termed as now induced dipole. ले जाओगे घर से बाहर, चलना पड़ेगा आउटिंग पर मेरे साथ, right now? So and now as these poles are present here, again opposite poles, now the picture is clear to you, they will attract each other. And this weak force is termed as instantaneous dipole, induced dipole. Remember, condition for this, both molecules should be non-polar. Like if you have a gas cylinder filled with oxygen gas and nitrogen gas, as both gases are non-polar, but the condition is the gases should be non-reactive. They shouldn't be reactive. Clear? So in such type of situation, when both are non-polar, the force taking place between these is instantaneous dipole, induced dipole. Got it? Let us move ahead now. The next fourth category is ion dipole. After discussing all the fours, we will be talking about their comparative strength. Although all van der Waals forces are very weak forces, not strong ones, but in those weak forces, again, we may categorize them on the basis of their comparative strength. So this is ion dipole. Now, from name it's clear, the first component or first particle is ion and the second one is a polar molecule or atom here. Ion and this one is a polar one. Ion can be cation or anion, any. Cation or anion. For example, you have chloride ion and a polar molecule, HCl, HBr, any polar molecule you can take, like HCl, polarity is there. So this negative charge and the positive pole, they experience a force of attraction. This force is termed as ion dipole force. It can be with cation even, because we talk about any kind of ion, cation or anion. Understood this thing also? Now coming to last category, that one is ion induced dipole. Means one is ion, cation or anion, and the second one is non-polar. Ion induced dipole. The first one is ion, that is cation or anion, again any ion or anion, and this one is non-polar. In similar way, we can represent this, that chloride ion, or you can take any cation, neighborhood, non-polar, hydrogen molecule, no polarity is there, but this electron cloud will repel the electron cloud of hydrogen and pushes it towards right side. When this electron cloud is pushed toward this side, it becomes slightly negative, it becomes slightly positive. And now these opposite poles, they attract each other. This force is termed as ion-induced dipole because this ion has induced polarity in its neighboring known polar molecule. Yes, my dear children, now I think all forces are clear to you in absolutely well. Now try to decide the comparative strength of these forces. The strongest one, more are the charges, more is the electronegativity difference, more would be the strength. Simple concept. So, the strongest one will be which one? This one. Ion dipole, because a permanent charge is present on ion. And the second one, as it is polar, so here also charges are present, although slight charges, but charges are present in this case also. So the strongest one is ion dipole. Now just categorize all these forces. How we categorize them? The strongest one is ion dipole. Then the next one is dipole. Next comes is ion induced dipole. The next one is, after ion induced dipole, which one? Again, in case of induced, one more is there. Yes, that is dipole induced dipole. And the biggest one is London force. So this is the decreasing order of strength of van der Waals forces. Now coming to second parameter, which also decides or plays an important role to decide the physical state of matter. That second parameter is thermal energy. Due to temperature, molecules possess thermal energy, or we can say kinetic energy. Clear, children? Due to temperature, molecules they possess thermal energy, or we can say kinetic energy. More is kinetic energy, more would be the movement of particles. And more movement means you are moving from solid to liquid to gaseous state. So in this way, we can say on increasing thermal energy, we are moving from solid to liquid to gaseous state. Gases, they possess maximum thermal energy. Solids, they possess least thermal energy. And in terms of intermolecular forces, we were saying on increasing intermolecular forces. Intermolecular forces, in terms of this, on increasing intermolecular forces, we will be moving from gaseous state to liquid to solid. So, to decide physical state, a perfect balance should be there between these two. If thermal energy is towards higher side as compared to intermolecular forces, of course, the physical state would be gas. But if intermolecular forces, they dominate thermal energy, they are towards higher side. In that case, the physical state is solid. Both are at balanced rate, then it is liquid. So my dear children, now I think there is no confusion regarding the reason of physical state at room temperature, that why different substances, they have different physical states under similar external conditions. Got it? Coming to next topic of this chapter. Now, after talking this, we will be taking gaseous state in detail. we will not be taking liquid in much detail, and solid we will not even discuss, because solid state we will be doing in 12th standard. Liquid only we will be doing very few properties. Why? Because it's a part of physics syllabus. In physics, you will be doing this in fluid unit. So that's why in chemistry, we will be discussing gaseous state in detail. So first, we will be starting with gaseous state. First, very simple characteristics of gases which you all know well. They have a well-defined shape and volume. Yes or no? No. I try to catch the problems. They neither have definite shape nor definite volume. Shape and volume both are not fixed. They take the shape of container as well as they take the volume of container. Whatever is the volume of container, that would be the volume of gas. So this is first very important characteristics of gas. Then we can say intermolecular forces are almost negligible. Then we can say rate of diffusion is very high. Yes, no? Rate of diffusion is very high. Then we can say the next characteristics, density is very low as compared to solid and liquids. Clear? Then we can say they exert pressure in all directions. Exert pressure in all directions. Right? Next characteristics we can say about gases, that as they have no definite shape, no definite volume. Can we say no definite mass? No, the mass is. Next characteristics, so these are they are highly compressible. Highly compressible. So these are the main features of. So children, these were the general characteristics of gases. So in this video, we covered the reason of existence of different physical states, and secondly, what are the main characteristics of gases. Now in next video, we will be talking about all gas laws, that what are the main laws which are affecting the properties of gas. Okay.